Hello, folks. Welcome to Rational Science, directly from Frankfurt, Germany. It's about 9 o'clock over here, 9 o'clock at night here in Germany. Anyways, last week I went to the Oktoberfest in Munich, and great party. We had a great time with my wife over there. We always meet friends that invite us every year. We haven't gone in a couple years because of the COVID, but this time we had a great fun. Some of these people we've known for 40 years now, so we get together every now and then just to find out how things are going. Anyway, from there I went to Salzburg, Austria, and I went to visit another great friend of mine, and she's a businesswoman, great lady, and she's the patron saint of dissidents. She does help a lot of dissidents out there, people who fight against the establishment. She's very strongly against all the stuff that's coming out of the establishment. And so she's helped a lot of people. And she was the one who organized the what was it, the second Rational Physics Conference in 2014. Some of you who were there, you probably remember this. See if I can show this. Okay. And I presented my rope model over there. Okay. And other people were able to present their opposition, especially to the establishment. Okay. So, she's the one who organizes. Again, she's a great lady, great businesswoman. She's done very well in her life with especially helping dissidents. And, we should all keep her in mind, all of you who know her. And so I went there to baptize her. Okay, I went there to baptize her, and I baptized her as Santa Monica. Okay, she's Santa Monica, the patron saint of dissidents. Okay, grand old lady. I hope all of you who know her know who I'm talking about. Okay, and yeah, we owe a lot to her. So just keep her in mind. Um, for different things. We might even have another conference, maybe in Austria, Salzburg. Okay, great city also. And I think she had two of them over there. Anyways, after that, I came back, and I came back with a cold, so I'm a little congested. Took an aspirin a little while ago. I hope I don't sneeze or cough too much. Okay, so let's see how it goes. Anyways, today I'm going to be talking about Flatlanders. Okay, who are the Flatlanders? Well, there's several sects of this religion. You have the flat earthers, you have the flat universers, and a lot of other flatlanders out there, people who propose or who deal with the world of flat. And one question I have with that is that they never define the word flat. They don't know what flat is, okay? But that's not the reason all these people are flatlanders. They're flatlanders because they use the wrong language. They use the language of mathematical physics, the one that most people learn in high school, college maybe, And I would say 99.99% of humanity is a flatlander. And they use these words here. These are words that if you use these words to make your case in physics, you are a flatlander. Okay, so here they are. These are some of the words. They're not all the entire vocabulary. But if you use words like waves, and you can say, oh, the wave did this and the other and this other thing. Use the word ether in any way, shape, or form. You use the word space-time, black hole, plasma. A lot of the electric universers, they can't live without their plasma, their beloved plasma. They also talk about vortex. Mainstream usually talks about dark matter, dark energy. They use these words such as mass, time, force, charge, field. At least the establishment uses the word particle quite a bit. Usually dissidents use the word wave, okay? And they all like to do experiments, measurements. Some of them even do equations. All these folks are flatlanders. None of this has anything to do with science, let alone with physics. Okay, so we treat them as flatlanders. And yeah, some people say, Bill, you're offending us. You're ridiculing us. And all I can say is, no, I treat you with the respect that you deserve. Okay? So that's how we handled it here. Okay, so here's the mainstream flatlanders. Okay, what do they believe in? Well, here you have a synthesis. Okay, you have the flat universers. They believe that the universe is flat. Okay, this is what they talk about, the flat universe. And they include also the quantum mechanicers. Okay, so you have these two groups. You have one that tries to unify them, known as string theorists. Okay, and what's the problem with them? Well, they are irrational because they are in the business of moving mathematical concepts. Some of the words that you just saw, those are mathematical concepts. What they do, they reify them, they turn them into physical objects, and they then begin to move them around. And here you have some of those words: time, space, time, energy, mass, field, particle, wave, black hole, dark matter. All these are concepts. None of these are physical objects. You cannot use these terms as nouns in physics. Big problem with them. They use the atomic model created by Niels Bohr and Ernst Rutherford, okay, which is the planetary model. Looks something like that. Okay, this is the hydrogen atom, supposedly. It's got a positive proton in the center, proton ball. We clarify that. It's got a little electron bead moving around it or somewhere around it. No one knows why the bead, the red electron bead, doesn't fall to the nucleus. In fact, that's what triggered quantum mechanics, the study of why that little bead doesn't fall to the nucleus. But then there's the question, why doesn't it fly out of this solar system, this little tiny solar system? You know, why does it orbit, or why does the bead stand around the proton bowling ball? That's the question. It doesn't fall to the nucleus, it doesn't run away, and we have no idea what this positive and negative stuff is all about. Okay, so that's their atom. And of course, if you can't answer those questions, then obviously you're not going to have a very rational theory, because your hypothesis has not been constructed properly. You do not have the proper foundations. Okay. What is gravity according to these people? Well, they use concepts to explain a concept. The concept is known as gravity. Gravity is not a physical object. Gravity is what we're trying to explain. Okay, and they use these words: time, energy, field, mass. They work a lot on dimensions. Okay, then that's usually the cosmic world. Okay, quantum mechanics. They have these words that they've created: entanglement, superposition, decoherence, tunneling. They do not understand any of these words. They do not understand what causes these effects. All they do is they have named these effects. They use them for technology. And the problem there is that, people say, well, what is a quantum computer? Well, a quantum computer is a computer that uses these effects, but it's not because the computer proves quantum mechanics, the explanations, the physical interpretations of quantum mechanics. What these are just words that name the effects. That's it. It doesn't get beyond that. And so when you say entanglement, well, what are you saying? Well, you're saying this particle here affects that one over there without anything in between. And they cannot explain that. And if you cannot explain that, you're talking about black magic, okay? Because you're saying this affects that without anything between, without no physical cause. That's the issue. And then again, general relativity has all these terms there. And maybe the key one that I'm interested in is the little c equals a constant. It has been measured as a constant. People call it a constant, okay? Einstein proved it's a constant mathematically. In fact, it was people who came before him that did that. He just took the credit. But then everybody talks about FTL, faster than light. And you say, what do you mean faster than light? I thought special relativity was a done deal. It was proven that light travels at a constant speed, and it travels at 300,000 kilometers per second. It's the speed limit of the universe. But then people can't live with that, and they say, no, no, let me talk about faster than light. And look, you find all these papers. You just do a Google. You Google what I did there, the oxidative, and you look for faster than light, and you find all these papers. And I just put the first couple pages there a little bit. You'll find tons of papers. These are from the scientific literature, supposedly physics literature. And they all talk about faster than light. They want to prove faster than light. They say they observed it in the lab, etc., etc., etc. Everybody talks about faster than light, despite the fact that Einstein, I think, set the record straight, saying there is no such thing as faster than light. You cannot even travel at the speed of light, because if you do, you turn into so-called energy. And these people also emphasize experiments and equations, especially equations. They're into math. And they think that this is what science is about, and physics is about, experiments and equations. And when I challenge them, they say, Bill, you're doing philosophy. You're doing semantics. They don't like me defining words in such a way that they can't get away from, from the definition. They want to skirt the definitions. So they don't have definitions used for physical interpretations. What they've created, this language, mathematical language, with concepts of mathematics, okay, usually quantitative concepts, and they use them as physical objects like energy, mass, and force field. And when you call their attention to that, they say, oh, you're doing semantics. So that's the status today. Who are the dissidents? Well, there's maybe 10% of people out there, I would say, in the world that are dissidents, that do not accept the the explanations of the establishment. They think something's fishy about some of those explanations, and they had better. It means that it shows some degree of intelligence when you criticize the establishment, when they talk about black holes, Big Bang, dark matter. Of course, you're going to question a lot of that because it's all irrational. But what the question here is not the fact that the dissidents challenge the establishment. There's nothing wrong there. But science is not about criticizing. Science is about explaining what you offer in exchange. That's where science vibrates. And this is where the dissidents fail. Okay, and these are the dissidents here. Okay, you have these flatlanders. You have some which are from the electric universe, probably the main group that challenges the establishment. You have the flat earthers. But a lot of these people are really conspiracists. Not all of them, but a lot of them. And they have some political gripes, and they bring them into physics. In other words, they have some problems with the way the governments are run. And they say, well, everything's a conspiracy, everything's a hoax. And, I kind of draw the line between politics and science, politics and physics. I don't think you can automatically, extend hoaxes and conspiracies into science. And so that's where I usually confront these people. I'm saying that not everything in science is a conspiracy. There are interests, there are people who preserve their jobs, their income, their careers, and they will do everything to stop anyone who interferes with that. There is a lot of that going out there, but not because of that is everything a conspiracy, everything's a hoax. Now, these people usually use words such as ether, plasma. They use positive and negative. Dielectric. What is a dielectric? What physical object is that? They like to talk about electricity, actually current. They talk about the flow of current. It's like talking about a flow of a river, as I explained a couple weeks ago. The river's already flowing, so you cannot talk about the flowing river. Not in science. That's okay in ordinary speech. They talk about vibration of fields, force and charge, and all this other stuff. Counter space. Love that word. Counter space, it's the amount of space you have to put your beer on the counter. That's more or less what I think that is. Anyways, one of the problems is they use the same quantum atom. All these people, they use this model. The proton center and the electron bead somewhere around it. Usually they illustrate it as an orbit. Okay, sometimes they shoot in dynamical mode where the bead goes around the proton. Other times, they explain that the little bead stays within what they call orbitals. Okay, what is an orbital? Well, it's the orbit of many orbits. That's what an orbital is. They say the orbital is a region which the electron, all of it on its own, cannot jump across. So they have these lanes, so to speak, and you can find the electron bead somewhere in there. Anyways, the point here is that the flatlanders, the dissident flatlanders, they're no different than the establishment in the sense that they use this same atom. And this atom later is denied by everyone. They say, well, that's not the real atom. So which is the real atom? Until you can come in there and tell me what your atom, the one you're going to use in your presentation, you cannot tell me what your atom looks like, you cannot even start your presentation. You cannot talk about the flow of beads, meaning electricity. You cannot talk about plasma. You cannot talk about ionization because we don't know what your atom looks like. And if you are going to use this atom, then stick to it and say, well, this is your atom. You can't at the end of your presentation deny it and say, well, by the way, that atom I've used throughout my presentation, that's not the real atom. Okay, then show us your real atom, okay, before you start talking. That's the way we look at it. Anyways, flatlanders who are dissidents, they typically don't use the word time. They don't like these time things like time dilation, all that stuff. They're very strongly against that. Okay, so they are in general against all the conclusions of special relativity, all this time dilation, length contraction, mass increase. They don't like a lot of the conclusions of general relativity, especially Big Bang. They don't like that at all. They don't like space-time. They say, what do you mean space-time? What is space-time? They don't like the black hole, dark matter, dark energy, But one of the issues they have is that C, in many of their theories, or a lot of them at least, a lot of these dissident flatlanders, they think that little c is a variable, that the light does not travel at a constant speed. Okay, so this is not everyone believes that, but I'm saying that this is one of the things you'll find out there among the dissidents. Okay. They usually emphasize experiments. These are people who like to go to the lab and they say, let me do an experiment. Let's do an experiment to prove your theory or something along those lines. And they're not too much into math. They're not too strong on equations. They usually think that a lot of that should not be introduced so much, that you should do a little more, physical stuff, like go to the lab and so on. Anyways, these people also accuse me of doing semantics. Okay, when I hold them to definition, they say, well, you're a little too strong on definitions. You don't have to be so stringent, with that, so rigid. You should be a little more flexible, Bill. No, it's the flexibility that causes the problems. Because when you get around you make a definition, and then you deny it by going around it or going on a tangent that kind of violates your definition, then people can't follow your presentation because now you've cheated. Now you're not being held to the definition that you put forth. And so people say, well, definitions that's grammar. That's semantics, that's philosophy, that's ontology. Don't bring that in there. We're going to do science here. We're going to do physics. This is where the problem comes. Okay, so we have some built, and I'm going to show you some examples. Today, the examples are essentially going to be all these people who are primarily dissidents, and what they propose, how they think, and why they are flatlanders. Okay, all these people are flatlanders. They're going to use words like plasma. They're going to use the word ether, and I want to show you. I want to expose the way they think. And so what I'm going to be going through here are comments and questions that they asked these past weeks, and I'm going to put them there so that you can analyze, how these people think, or don't. We could say they don't, right? Okay, here's the first fellow, and he puts this issue here. He says, what's the confusion, Bill? Are you arguing semantics or what? Again, they think this is semantic. We're just using word wizardry here, magic words of incantation. Are you saying energy doesn't exist? So again, these people don't have it right. They've got the wrong idea of what we're doing here. We're trying to define these words, and energy is the problem with the word energy. Is first, there's no solid definition. They have several definitions of energy. The main one is that it's capacity. They say capacity, blah 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 blah. We don't care what comes after that. It's capacity. Capacity is not a physical object. So you cannot turn that into a physical object and say you transferred capacity. You cannot transfer energy. So the problem comes when they define it as a concept and they treat it as a physical object. That's the main problem with all the language of mathematical physics. And a lot of these people, they don't understand that. They say, are you doing semantics? Or what is this that you're doing? No, it's that you talk properly. We're going to hold you to talking property. You cannot start defining a term as a concept and then start bringing it as a physical object. You cannot say rock is a concept and then you use it to break a wall, or a window or whatever. That's where the problem is. And these words are treated as physical objects during the time that you do your physical interpretation. That's where it's irrational. That's where mathematical physics becomes totally irrational. Okay, so this is the issue. Okay. Here we have another fellow, and he says the following. Let me put this up here. It says, physics is application of scientific method to the study of physical world. Okay, great. Physics doesn't examine why something is, meaning cause, mechanism. That's what he's saying here. He says only how it is, meaning he's going to just describe it. It is completely descriptive, just like math. Well, the only reason that is so today, is that since the 17th century, the mathematicians made everyone believe that physics is about doing math and just describing mathematically. That's not what physics is about. Physics is the physical interpretation, not the mathematical description. And so this person, this individual, he believes that physics is just describing math, and for some unknown reason, it's very much like math. Yeah, of course, because math is not physics, physics is not math. Math is a description, physics is an explanation. And that's where we have a problem. When people say, well, I'm doing physics, and what they're really doing is mathematical descriptions. And she says this is why they work so well together. They work together because that's how it was defined for the last 400 years. That's the reason it is. It says no one else is using this definition of physics, meaning mine, right? And so if you came to this site, you're going to find something different than what you find out there. This is the only site in the world, on the planet, that says physics is physical interpretations and not mathematical descriptions. If you want these kinds of answers, you should be asking around philosophy department, not the physics one. The problem there is that, like you see in the picture there, the math guys send you to physics, to philosophy, and philosophy send you right back to math. Because if you go to any philosophy site, for example, the Stanford Encyclopedia of Philosophy, you'll find that all the concepts related to physics have come from math. That's where the philosophers got it. And the philosophers strongly believe in what the mathematicians have fed them. So if you go to philosophy, they'll send you right back to math. So it's not that I can go out there and to the philosophers and say, look, let me convince you guys, or let me show you you guys how this universe works. No, they're going to send you right back to math, and they say, no, the mathematicians already proved and through experiment how the world works. They've got all these equations, and then when you get to the irrational definitions, they say, well, that's an interpretation, and they get them all from the mathematicians as well. So there's no difference between mathematics and philosophy. Okay? And he says, you're using philosophic definition of explanation, your definition of physics. No, hopefully we're not, we're using a new definition of physics, which is explanation. Okay, that's what it is. And he says, using word games aren't productive. Again, these people think that we're doing semantics. Okay, they dismiss all this as semantics, as word games, as word wizardry, and that's not what we're doing. We're setting the foundations of physics. Okay, and the foundations means get your language straight right up front. That's what physics is about. Okay. Okay, here's another fellow, and he parrots the establishment. Okay, what does this fellow say? He says, the universe has no obligation to make sense to us. He got this directly out of the mathematicians. They put these words in his mouth. It's not that the universe has no obligation to make sense to us. You have to make sense to us. The mathematician who comes up with a theory has to make sense to us. And if he doesn't make sense, then it's irrational. That's what it's called. It's not, how can you say that he's explaining how the universe works when he's telling you in your face that he does not understand how this universe works? Entanglement, he says it works by action at a distance, whatever that is. It's known as black magic. And he says that's the way the universe works. You say, well, I don't understand it because you haven't given me a mechanism. And they answer, we don't understand it either. So we have a problem. And he says, there's always going to be another why you can add at the end of an explanation. No, there's one mechanism per question. So we answer one question at a time. And if people can't understand the mechanism, that's why you get the other why. Okay, but if you explain how the window broke, you say, well, a brick went through the window, you've answered the question. Period. We're done there. So there are no infinite whys, not in science. There's only one explanation, one mechanism per why, per question. And the difference between science and pseudoscience is that science is an ongoing process to go as deep into the why as possible. The first thing that we need to say is that nothing in science, nothing in physics, in mathematical physics, answers why questions. They do not do why questions. So this poor individual doesn't even have that idea. But then the fact that he says that science is an ongoing process, that is irrational. No, science is not an ongoing process. Science stops when you explain. Once you explain, at that point, science stops. Okay, so in the case of physics, we need to explain what we haven't been able to explain, or what the mathematicians have not been able to explain in the last 3,000 years, which is gravity, magnetism, electricity, how the atom works, and I must have missed one. What is the other one? Gravity, magnetism, electricity, the atomic works, how the atom works, and also how this universe works, essentially. Light also as well. So this is what they have to answer. And so far we have no answers from the establishment for any of those questions. Once we have those answers, we're done with science. It's not an ongoing process. You have to stop at some point and answer the question. And he says, if you manage to explain magnetism better than our current understanding, then congratulations. Everyone in the scientific community will happily accept a new definition of magnetism. The new definition of magnetism? What do you mean definition? What's this got to do with definition? You have to have an explanation of the mechanism. That's what you have to do. And the second thing is that no one in the establishment, in the so-called scientific community, will ever congratulate you if you tell them how this universe works, because they'll say that you have not followed mathematical physics. You need equations. They want descriptions. They don't want explanations. So no, you will never have an answer. Okay, this is the issue. And he says, if we did it the other way, any other way, you wouldn't be able to record this video and upload it to the internet. What is he talking about? He thinks technology is science. He thinks technology is mathematical physics. So he says, computers wouldn't work if quantum were wrong. GPS wouldn't work if general relativity were wrong. This is what this individual, he's just, all he's doing is parroting the establishment. That's all he's doing. Okay, so yeah, these are people who just memorize what the establishment feeds them, and they just absorb it, and they never question it. They just bow down to the priest. That's what it is. Okay, here we have another fellow, and he says the following. You can see how all these people think or don't. They're called Flatlanders. And this fellow says, the mechanism is the invisible magnet, and it's dielectric of positive and negative. Again, they bring these words positive and negative. They have no idea what that is, but they call it a mechanism. Okay? The atomic model of positive nucleus and the negative electron. Again, what are we talking about? Well, we're talking about the Rutherford Bohr model. They're talking about that. This is what this fellow's talking about. And yeah, this is not a rational model. So the positive, negative, the nucleus or the proton and the electron, this is an irrational model. You cannot start your presentation with that model because it's an irrational model, first of all. And second, because at the end of the presentation, they say, well, by the way, that wasn't our atom anyways. She says, our sun is an example of the production of that movement of positive, negative magnetic force as plasma. Big word, plasma. That some call the solar wind. Plasma ejected from the sun. What do you mean plasma ejected from the sun? How do you eject a concept? Plasma is that little moving thing that you find in between those two magnets. And as you can see, it's moving, and as long as it's moving, you cannot treat it as a physical object. You have to make it stand still. And if you make it stand still, you won't get plasma because plasma is a dynamic concept. And so you cannot eject plasma from the sun because plasma is not something that you can eject like a stone. It is a process. Plasma is like fire, okay? And you can say, well, the fire comes out of a dragon's mouth. Well, not in science, okay? That's in ordinary speech and in fairy tales. Okay, so he says, ejected by the sun by the solar wind represents all the elements produced by the magnetic demiurge of metaphysics, whatever that is. Okay, the machine is plasma, and the ether is the magnet dielectric that originally spun up to make the building blocks of all matter, light. You don't have to believe it, but it's a fact. Well, if it's a fact, I gotta believe it, I guess, right? And I guess this guy, he just believes it because he thinks it's a fact. That's what he learned by rote in high school or wherever, and he just spits it out. So he talks about words like plasma and ether and plasma being ejected by the sun. Next thing he's going to say that the ether vibrates. Can you believe that? Maybe. I don't know what he's going to say. Okay, here's another fellow, and what does he say about all these fantastic words that they use in Dissident Flatlander, okay? Flatland. Fellow says, the thing between the particles that makes them pull is virtual particles. Okay, so you have all these virtual particles that come into existence and out of existence constantly. And okay, let's even concede that. How do all these discrete particles pull two particles together? That's the question. Explain the mechanism to me. And he says this quantum theory principle answers, in the estimation of quantum theorists anyway, your basic objection. Now, this doesn't answer anything. But see, these people don't even know what they're talking about. If plasma, if virtual particles, ether, whatever you want to call it, is all these particles that are in the background, okay, let's concede it. Okay, so we have all these particles in the background. How do particles pull two particles together? Show me the mechanism, okay? No math, just show me the mechanism. Let's go to the lab and show me how you pull on a donkey by throwing particles at it, throwing stones, sand, whatever you throw at it. I want you to pull the donkey. Okay, when you explain that mechanism, when you show it to me in the lab, well, maybe I'll believe it. See, I can show you how I can pull with a rope. Okay, I tie this end, okay, to the donkey, and this to my hand, and I can pull on the donkey, and you can see the mechanism of how, with a rope, I can pull on the donkey. I can mimic, I can simulate the mechanism. Do the same thing with any kind of particles, virtual particles, real particles, fake particles, conspiracy theory particles, hoax particles, any particle you wish. I want you to throw the particle at the donkey, show me how the donkey is pulled towards you physically. Okay, that's the issue. So don't tell me you're going to pull with virtual particles. You're going to pull two particles, here we have two particles, and you're going to pull them together by what? By having particles between them? How are you going to pull these together with particles? That's what I want you to explain. The mechanism. We illustrate, that's fine. Then I'll believe. Okay? Just show it to me. Show me the mechanism. Not even God can do that. Okay, here's another fellow. He says, gravity didn't create all the stars and black holes. A collision did. The Big Bang Theory is an utter fact. All these people, they talk about fact. They know everything. They're so arrogant. They know it all. Okay, so you can't even talk to them because they're not even listening. They just want to teach, and they tell you Big Bang Theory is a fact. Okay, so how does he explain this? Well, he says all energy, including gravity, okay, energy is a concept, gravity is a concept, is a manipulation of field. Another concept with energy, another concept, no energy, no gravity. All concepts so far. So far we haven't learned anything. All he said is that love is made of intelligence, which is made of data, which is made of who knows what. Okay, energy is energized dark matter. Okay, we finally know what energy is. It's energized dark matter. I like the fact that he defines energy with energized. Okay, that's great. The energy a mass ejects from an object is replaced by the pressure of space. The pressure of space. I thought space was nothing. So this fellow says that space somehow is a something and it causes pressure like a piston, I guess. All this pressure that is upon us from space, it's squeezing us, right? This manipulation causes the force of gravity. Okay, so far we haven't learned anything because so far all he's mentioned is concepts. We don't have a physical object in that whole, in those paragraphs or those statements. There's not a single physical object. He cannot make a movie of anything that he just put in there. And he says the gut, the grand unified theory, is about gravity, and space caused it. Space causes it. Space causes gravity, okay? Gravity is a manipulation of the field of space with energy. Now you learned it? Finally we know after 3,000 years. A theory must be able to be explained to a 6-year-old, and my theory is the one that can do it. Absolutely loved it. Okay? How ignorant can these people be? I mean, what are these? I ask myself when I read some of these comments, these questions, right? I ask myself, what are these people doing in physics? What are these people doing in science? They should be in church on Sundays praying for their salvation. They don't have the mental capacity to do physics. They don't even know the basics, the foundations, nothing. They just come up with theories. They say, oh, I think I got it. You know, they come up with a couple things there and they say, I think I know how to explain this. And they say the most absurd things. Why? In great measure, because they don't have their language straight. Okay, that is what the issue is. Okay, here's another fellow talks about the origin of the universe. Let's find out how the universe originated. You know, matter. Okay, here it is. He says, the beginning of the universe is unknowable. The beginning of the universe is unknowable. No, it is knowable. We know it for a fact. There's no question about it. Let me explain the origin of the universe so that you understand it and you know it. Okay? I'm going to explain the universe so that there is no doubt about it. Okay? You learned it here for the first time. Okay, here it is. Okay? I put it up here so we have something to, let me put it on this side. Okay, learn it right. You can put it as a prayer tonight. You know, when you pray next to your bed tonight, okay, read this prayer. Okay? Something, that which has shape. Nothing, that which doesn't have shape. Okay, something is an antonym of nothing. They are opposites. One has shape, the other one is that which does not have shape. Okay, we got that so far? Okay, now this is the first law of the universe. I want you to memorize this. Read it every night. Make it your Lord's Prayer, you know. Something can't morph into nothing. Nothing can't morph into something. We got it? Okay? You cannot turn something into nothing. You cannot turn nothing into something. How does nothing acquire spontaneously or, you know, all of a sudden, you know, length, width, and height and become something? And how does something, which has length, width, and height, suddenly lose length, width, and height, all three dimensions simultaneously and become nothing? If you can explain the mechanism, with or without God, I'll concede God to you. I'll concede God. You want to do it with God, do it with God. No problem. Bring God into the picture. Show me how God converts something into nothing or nothing into something. If you cannot explain the mechanism, you don't have a rational theory and you cannot say something came out of nothing. You cannot talk about the origin. You cannot talk about creation with or without God, because you cannot explain the mechanism of how something came from absolutely nothing, again, with or without God. And so what do the relativists do? Well, they created a theory known as the Big Bang Theory. And the Big Bang Theory goes more or less like this, okay? They say, look, the way we see it today, the universe is expanding. All galaxies are receding from all other galaxies. The universe is blowing up before our very eyes. It's the balloon inflation theory. You know, you have this inflating balloon, it gets bigger and bigger and bigger, okay? And let me get this out of here for a second. You know, here you have the balloon, it's getting bigger and bigger and bigger and bigger. And because it gets bigger, all the galaxies are on the surface. Allegedly, this is the general relativity version. So because the balloon is getting bigger, the galaxies are receding from each other because they're like polka dots on a balloon that you inflate. So you inflate it, and the balloon gets bigger, the dots get farther away from each other. That's the theory. That's where we are today, according to mathematical physics, according to general relativity. What happens when you uninflate, when you pinch the balloon, so to speak? It becomes smaller and smaller and smaller. The galaxies come closer and closer and closer together. That means if we were to run the tape, you know, the videotape backwards, right? We would arrive at square one, right? And we would see that all the galaxies somehow converge upon a point, okay? Point, infinite mass almost, you know, very heavy point, very massive point, small point, and they call that the singularity. Okay, so this is the starting point, so to speak. Okay, you have the singularity, and it's this little, I mean, you can conceive of it or think of it as a little point, a little speck of dust that weighs as much as all the matter in the universe. Okay, think of it like that. You can say almost infinite mass in a tiny speck of dust. Okay, that's what you're supposed to think of it as. Okay, and you say, okay, where did the speck of dust, where did this grain of sand come from? This so-called singularity, which is really a zero volume infinite energy. You know, it's just energy there. In the middle of what? Because, you know, that also, that singularity contains space as well. So we don't know what's outside of space. They say there's nothing outside of space, but that's what space is, nothing. So we have a little bit of a contradiction. But what's the problem with a Big Bang Theory? The Big Bang Theory is this. They take you to square number two. They take you to frame number two in the movie, okay? They don't take you to frame number one. We don't know how the little dot came into being, the little singularity. How did that come into being? And then what's the black stuff? Because if the little dot includes space, time, and matter, what is the black stuff on which against which the little thing is expanding? And that's when they say, well, it's not expanding against nothing. It's expanding against nothing, or there is nothing outside of it. And you say, well, that's what space is. That's what's inside of that little dot. Nothing. Space. So what's the black stuff? That's outside of space. So you got to define that. You got to tell me what it is. And they say there's nothing there. So we have an object, supposedly the universe, which is that little dot, which is encapsulated by nothing, which is what space is, which is inside the universe. Okay, so you don't even have God there on the outside or dimensions or anything. Anyways, the issue is that they take you to frame one, they never to frame two, they never take you to frame one. We have no idea how the dot came into being. And the reason the relativists say, well, we never go to frame number one, we always go to frame number two, because we cannot tell you how that dot came into being. And the issue they're evading is what the religious folk throw at them. They say, you're trying to avoid God. God made the singularity. And so they get into this fight, well, who made God? And they say God's always been there, and blah, blah, blah. You know, they get all these fights between the religious folk and so-called religious folk and the so-called physicists, the mathematical physicists, the flatlanders of the mainstream. And they get into these debates on, you know, whether God exists or not. And they say, well, we don't believe in God, but we're not going to tell you what happened in frame number one because we don't know. And we start at frame number 2, which is where the singularity is already there, and it expanded, exploded, and we don't know what happened before that. So we don't have a moment of creation because we don't know how the singularity was created. Okay? And the other guys say, well, God. And what is God? Well, God is eternal. But for that matter, we can just say that matter is eternal. Doesn't that solve the problem? We get rid of God and we get rid of Big Bang, both of them. We just say matter is eternal because matter cannot turn into space. Space cannot turn into matter. Something cannot turn into nothing. Nothing cannot turn into something spontaneously, right? All of its own. Even with or without a cause. I mean, explain the mechanism. If you cannot explain the mechanism, then we do have an answer to creation. It never happened. Okay, we got that? Okay, we have some people who criticize the rote model, some of these flatlanders, right? We're today's flatlander day, okay? And one fellow says, and this is a very common question, I like to put this up there because these people really, they start off on the wrong foot. They're not even qualified to ask questions because they don't even know what to ask. And so they ask one of the dumbest questions ever. And here it is. It says, ropes are made of what? Ropes of what? What are the ropes made of? People ask this stupid question. And you say, well, are they that lost? Go to the hardware store and ask for a 2-strand rope. And when you get it, you'll get something like this, right? What you see there. It's made out of 2 threads, 2 strands, 2 wires, 2 strings, whatever you want to call them. And they're wound around each other. And we call this a rope. Was that so difficult? Yeah, a rope is made of 2 strands. I'm sorry that you never heard of that you never learned this in kindergarten. Maybe you flunked kindergarten, I don't know. So we have to show them how our theory is constructed, okay? And our theory says that this is all that exists in the universe, a single closed loop thread. This is not the real thread, okay, by the way. This is just a simulation of what we're proposing, okay? We're saying, let me remove this here for a second. We're proposing that this is all there is, ultimately, okay? A single closed loop thread. You can simulate it with a rubber band if you want to explain it to a kid, okay? That's all there is. This thread turns into every atom and every rope that interconnects any 2 atoms. That's it. See how simple? We live in a very, very, very simple universe. Okay, I know you've been taught otherwise. You're saying we have a complicated universe. We cannot understand anything. We'll never figure it out. Science is an ongoing process of discovery where we don't discover, we never find, we only seek. No. At some point, the buck stops here. You have to explain. And to explain, you have to have foundations, definitions, and the objects that you're going to use to explain your theory. Okay, that's the way it works. Your mechanism, you're going to explain a cause. Okay, so this is the starting point, and this is more or less what it looks like. Here's a synthesis of that, okay, for those of you who are new to this site. Okay, here it is. We have the single closed loop thread, which is the rubber band I just showed you, okay? It twines around itself, all around the universe, and it creates that universe that you see on the upper right-hand corner. All atoms in the universe are physically connected to all other atoms in the universe. All these atoms form galaxies, stars, planets, asteroids, comets, everything you can think of, even the gas that's interstitial, between galaxies, interstellar, intergalactic, all that stuff. So we're saying all this, if you were to unwind that entire universe that you see there, it would look like that single closed loop thread on the upper left-hand corner, okay? So this is what we're proposing. This is what we're saying the universe is. What's the black stuff in the background? That's known as space. What is space? Space is nothing. What is nothing? It's the opposite of something. What is the opposite of something? That which has no shape. Okay, so space has no shape. Space is nothing. Nothing is a concept. Okay, do we have that? Nothing is a concept. Okay, and no, matter is not really floating in a concept. Matter is simply related to matter. Okay, it's not related to the background. The background simply forms this backdrop that kind of chisels, you could say, matter. We're only concerned about matter, not about the black stuff, because the black stuff is not there. Okay, it's not a thing. Okay, it's not a container. Okay, so what happens with these interconnected atoms? Well, there you see it on the lower left-hand corner. It's in a dynamic mode. You have the 2D version and you have the 3D version, okay, of the atom, the simplest atom, which is an electron shell that encapsulates the proton star. They're connected by a rope, and as the atom expands and contracts, it torques the rope, and that is known as light. Okay, that's the in a synthesis, that's in few words, that's what the proposal is. Okay, that's what we're proposing. That's how the universe works. That's what light is. And here we have the construction of the atom, okay, so that you can see it better. Okay, you have two threads. One twines around and encapsulates the one in the center. That comes from every atom in the universe. It's a little star in the center there. Okay, so you have all the ropes in the universe converging upon our atom. They all crisscross in the center, and they form this entity which, as you can see, has ropes converging upon the edge, the electron shell, as we call it. And one of the threads goes around, the other one goes through the center. Okay, so this is the construction of our atom. It's constructed out of the same material, the same threads that form the ropes, and we have a single closed loop thread in the entire universe. That is our proposal. Bottom left, you see our 2D atom. Here you see it bigger. That's what it looks like. Ropes converging upon the electron shell, and the one thread goes to the center of the atom, which forms all the threads from the universe, converge upon that center and form the proton star. Okay, and immediately people think about touch. They think about our experience in our macro world, and we have to correct them there, because we say that, first of all, an object is not that which you can see or touch. It's that which has shape. The rope, the atom, the threads all have shape, okay, but they do not have the ability to see or touch, especially touch. Okay, they can't touch each other. They go right through each other, and people have a lot of problem with that. They say, "What do you mean they go right through each other?" Because it offends their everyday experience. But again, an object is not that which you can see, touch. It's that which has shape. We meet the definitions. These things have shape. The thread, the rope, the atoms, they have shape, but they cannot be touched by humans or between them. And that's a part of the foundations. People say, "Bill, you're avoiding the question. You're just making an ad hoc assumption." And we have to make that assumption. We have to make that assumption because we have to explain Mother Nature's universe, not the one you want, not the one of our macro world, not the one of our ordinary or everyday experience. We have to explain why this pencil, right, falls to the floor, okay, and and you see nothing above and nothing below, and you can't touch anything above or below. And so hopefully whatever's here, right, is untouchable. And if you can touch it, that'd be great, but we can't touch it. And so we have to make our assumption, the foundation of this theory, we have to make it untouchable to mimic, to simulate Mother Nature's world. Not the one we want, not the one we say, well, how come I can't see or touch it? Well, because it's Mother Nature's world that you're analyzing. Her world you cannot see or touch, which is the mediators that cause this. And if you say there is nothing here, then you're doing black magic. You're doing everything by action at a distance, and we do not understand your mechanism. Okay, so that's the issue. Okay, another fellow brings up another issue, and again, all these are Flatlanders, the way they think, or don't. Okay, this fellow says, you state the rope connections between objects change from a coaxial to becoming spread out, increasing the number of independent connections. Exactly. In your model, the number of rope connections to all atoms don't increase, and the tension and length of the ropes remain fixed. Correct. How does changing the angle of the ropes add acceleration to an object? So I guess this fellow doesn't understand. Okay, he's never visualized this, what he's trying to figure out there. Any real physical, I like the arrogance. They say, any real world physical examples of change in angle producing an acceleration between objects using ropes of fixed length, number, and tension? Aha. Okay, so this is what he's bringing up. He also brings up the next issue, which I think is the same fellow. He says, you forgot to draw the trillions of ropes connecting the astronaut to every star in the universe. You also have not justified why the astronaut would fall towards the Earth in the first place. Are there leprechauns pulling on those ropes? What about the leprechauns pulling in every other direction? Okay, so the first thing we have to educate this poor fellow on is Newton's equation. I guess he's never been familiar. He's never been, educated on Newton's equation. It's got a little d at the bottom, and not r like the people from mathematical physics put down there. It's not an r. It's not a radius. Okay, and there's a lot of reason for that. I've talked about that in the past. It's d for distance, always. Okay, never put a little r there like the mathematicians do. Okay, now what is it? Weight. You have weight, and you can see the weight of an astronaut, 25 kilograms there outside of the Earth, is different than him being closer to the Earth. And the only thing that's changed is distance. Okay, so he's at a certain distance at 25 kilograms and a different distance at 50 kilograms. Okay, so he weighs differently depending on simply location. Weight is a static concept, really. It's location dependent. If the astronaut moves 1 millimeter, 1 inch, 1 foot, 1 yard closer to the Earth, he already weighs more. Just by changing his location, he has a different weight. And people don't always understand that. In fact, the people who don't understand it are people from Newton all the way to Hawking. All these people who are mathematicians, they don't understand that. That weight is a static concept. Weight is location dependent. Different location, different weight. You move 1 inch closer to the Earth without moving. If you could just stay there in space, you would weigh differently than if you are farther out. That's how simple it is. And this fellow doesn't understand that, and so it's very hard to talk to people who do not understand Newton's equation to begin with, okay? So here, let me show you this, okay? See if we can clarify that with a little bit. Here it is. This is how gravity works, okay? This might answer his questions. There you have a cube and a cylinder, okay? As the cylinder approaches the cube, okay, you can see what's happening with the ropes connecting one atom in the cylinder to several atoms in the cube. When the cylinder was farther out, all the ropes were on the same axis. They were one right behind the other. In other words, they were all on the same axis because the atoms are all aligned. Okay, but what happens when the cylinder approaches the cube? Just by location, just by changing the distance, you can see what's happening to the ropes. They immediately fan out, and each rope is acting independently. That's what we mean by independent ropes. The ropes have not appeared out of nowhere. The ropes were not created. The ropes are not pulling. The word pull is really outlawed. We use pull for the concept known as gravity, but not for what's happening between each of the ropes. The ropes are under tension, and tension is not a force. Tension is not a pull or a push. Tension means that no one wins the tug of war. So those ropes are under tension, which is really defined by the velocity of light, c, okay? And all that's happened here is that the ropes fan out. And because they fan out, each one acts independently. And then at the bottom, you see another simulation of what we're talking about. We're saying when the cylinder and the cube are very, very far apart, you can see all the ropes form a single coaxial. It's like we're a single rope. So distance is very important when we're talking about gravity. But as the cylinder approaches the cube or vice versa, you can see what's happening to the ropes. They fan out. And that's the acceleration of gravity. On the right-hand side, you see on top the way the mathematicians talk about a spoon. They say, well, it falls and there's nothing pulling or pushing on it. And on the bottom right, you see our version, which is every atom of the spoon is connected to every atom of the earth.
As the spoon falls, all the ropes fan out, and that's the cause of the acceleration of gravity. That's what causes uh, gravity. That is gravity right there. Okay. And here's an experiment that, not an experiment really, it's a simulation. People are going to say, oh, Bill, you're running an experiment. Okay, I want you to see, I made this device because I use it as a didactic tool to teach. Okay, this is just so that you can visualize gravity, which is what this fellow says. Tell me how you produce gravity. It looks something like this. Okay, see if I can. Okay, this is the device. Okay, see it there. You can see it maybe better. Okay, this is the device, and I'm going to set it in motion. Okay, with a little video because it's probably you'll see it better through the video. Okay, so you can see how gravity works. Okay, so keep an eye on the device here, and you'll see how gravity works. Okay, this is what we're proposing. Okay, we're saying that as an object approaches center of gravity, maybe the earth, maybe the sun, whatever, you can see what happens to the ropes. Behind the hand, they form a single coaxial, and in front they open up. Okay, so when we push it forward, you can see what's happening to the ropes. They change the angles, and any rope that was on that same axis would be tugging or would be acting independently. Okay, but look what happens behind the hand. They all form a single coaxial. And when you move outwards, you see the same effect. Okay, so again, this is just a simulation. Okay, you have Newtonian gravity on the left-hand side and what I call the linear regime on the right-hand side. Okay, one more time, there it is. Okay, just to show you how the simulation works. Okay, simple device that can tell you what happens with the angles of the ropes as an object approaches the earth or maybe the sun, and what happens behind it. Okay, so when you leave the solar system, you're going to enter that linear regime. Okay, it's going to be almost a straight line all the way to Alpha Centauri or the next star or whatever. Okay, okay, so this is just a simulation so that you can see how we're imitating this, how we're simulating, gravity with this, the angles, okay? And of course, when you change the angles, what you're doing is getting ropes that are now out of alignment. They're not on the same axis any longer. Now they separate, and now each one is acting separately because you have an atom at the end of each one of those ropes. Okay, so distance is a very important thing. Yeah, the moon pulls on us, but the moon is so far away, a little over a light second away from us. And so its influence on us is very little because it's almost a single coaxial, more or less. Okay, so this is how you're supposed to see it. The moon is essentially tethered to the earth. Okay, now fellow, he brings up another issue. He says, gravity goes right through things. Well, that's from Professor Muller, which I talked about a couple of weeks ago. And he says, this guy doesn't believe it. He says, like it goes through a wall? Yeah. You never figured this out, that gravity goes through the wall. It pulls on him right through the wall. The earth is pulling on him right through the ground, the floor that he's stepping on. He never realized this. And these ignorant people, they come here and they want to teach you something, or they want to laugh. They make fun of you. And then they complain when I make fun of them. See? So yeah, they're very ignorant, very arrogant people. And he says, the object, the wall, doesn't move. You're right. Yet the motion of the astronaut on an object is affected. You didn't even spell that right. I can't find a reason and rationale, again, didn't spell that one right, in the explanation. Okay, something to do with a moving concept called angular momentum between objects? Or the wall is connected to the ground, the astronaut isn't? Again, these people are so ignorant. And this comes from Mr. Muller, who said the following. Okay, he says, professor at Berkeley, he says, every atom on the earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. It goes through things. And people should really memorize all that. They should pray every night using this prayer. Every atom on earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. And people have problems understanding what I just put up there. Maybe I should leave it there for an hour until you memorize it. Okay? Yes, this comes out of Newton's equation. You can't avoid Newton's equation. Newton's equation is well firmly set in place. Okay? So, you can do all the experiments you want. You'll come up with Newton's equation. Okay? Newton's equation is right on the money. And, you're being pulled right through the floor by the earth. Every time you jump, why are you pulled downwards? Something is pulling you, I guess, from underneath the floor. Why can't you jump to the moon? And this fellow never discovered that the gravity goes right through the wall and pulls on you. Now, it doesn't pull you through the wall because there's not enough matter sideways. All the matter is underneath us, and you're very close to that matter. You're also pulled by the moon, but you're very far away from the moon. That's why you don't fall to the moon. That's why when you jump, you're pulled more to the earth than to the moon. Some of these people don't understand even these basic things, and they claim to know how this universe works. They want to teach you, and they want to laugh at you the way the ideas that you have. And they're so ridiculous because they don't even know the basics. They don't even understand the foundations. Okay? I mean, if they would have gone to high school, at least they would understand some of these things. But they don't even have this basis, this foundation. Okay, and another fellow says, I wonder why the space station doesn't actually fall down and how come it orbits the Earth without propulsion. You're wrong. There is a propulsion. Okay, so the space station, the ISS, right, International Space Station, does have propulsion. Okay, and so I put in there an answer. The ISS does have propulsion. It must accelerate forward. It travels faster than the spin of the Earth. The Earth spins, and this thing goes, several times, 16 times around, 16 times as fast as the spin of the Earth. It goes through the top of your house 16 times during the day, while the Earth, the cloud that would go all around would go just with the spin of the Earth. Okay, so yeah, this goes faster than the spin of the Earth. It travels around the Earth around 16 times faster, right? The ISS is a kite. Let me repeat that. The ISS and every satellite you see out there is a kite. Every probe that's ever orbited the Earth, the shuttles, kite. They're all kites. Every single one is a kite. Every single atom of that device is stuck to every single atom of the Earth. That's what's keeping it in orbit. But if it just stands there, it'll fall to Earth, like, just like this. If this is just, if it stands still, it doesn't move forward, it'll fall. But if, like Newton said, if this moves forward and moves at a fast enough rate, fast enough speed, then it'll stay in orbit. Newton showed this 400 years ago. Come on, guys. And so every atom that comprises the ISS is bound by electromagnetic ropes to every atom that comprises the Earth. The Earth swings the ISS around, okay, like this. Okay. Like a boy swinging a ball at the end of a string. And here I'm going to illustrate that for you, okay? Little bit. Here's the ISS just standing still. This is the version that mathematical physics would show you. They say, look, the ISS is just for no reason whatsoever, just up there, and it doesn't fall to Earth. And for some reason, we have to accelerate it, propulsion, okay? And what we're proposing, we're saying, no, this is what's happening, okay? That's the real thing. We just can't see those ropes. You can't see or touch them. That's what's holding on to the ISS. That's why the ISS does not leave the Earth, okay? So that's the issue. And here you see, okay, this is what you're seeing there is the ISS going out around much faster than the Earth. The Earth spins around, and you can see that, the ISS just goes much faster than the Earth. It's like a boy spinning, again, a ball at the end of a string. That's everything works like that in the universe. The Earth is also swung around by the sun. The moon is swung around by the Earth. So on down the line, we're swinging the ISS around. That's why it doesn't leave the solar system. Why? Because what did Mr. Muller say, Professor Muller? He said,
every atom of the ISS is bound to every atom on Earth. Every atom on Earth is bound to every atom of the ISS. Got it? So the Earth swings the ISS around like a boy swinging a ball at the end of a string. And here you see it a little bigger. I put it up there so that you can see it better. Give me a second here. There it is. Ah, I thought I had it right. Give me a second here. There it goes. Okay, so that's what's happening. Okay, the ISS is a kite. That's all it is. It's being swung around the Earth as the Earth rotates. Simple. That's our theory. Okay. Any questions? Put them there and we'll address it next time. Those are for people, Flatlanders, who don't yet understand what the rote model is all about. Okay, we also have the etherists, and these people are, Flatlanders. They believe in the ether. They introduce the ether for everything. Now, I do clarify, and I have clarified, that the establishment also believes in the ether. The ether has never abandoned us in the last 3,000 years, because everybody thinks that there is some kind of entity out there, which they call the ether, that either vibrates or serves as the foundation for light, maybe even for gravity. It's the background energy. It's the cosmic background radiation. They got all these names, the false vacuum, space-time. They have all these names for it. It's known as the ether. It's never changed. Okay, it's always been the ether. Okay, and so I also mentioned a couple weeks ago what any etherist has to answer. These are your action items. You can't put a comment unless you answer these questions. Otherwise, your comment or your question or whatever you put down is, nonsense. You have to tell me what the ether is. You have to define the ether. If you're going to define it, if it's a concept, if it's an object, I want you to point to it. And here are the action items. Here it is. Okay. Is it an object? Is the ether an object or is it a concept? That's the first question you got to answer. Okay, for that, you need to know what an object is, what a concept is. So if you don't know what these are, you got to define those words as well. You got to tell me how an object is different than a concept, how a concept is different than an object. And here we have definitions. We work first from definitions. Every word in the dictionary is either an object or a concept. Can't be both. Okay, so either God is a concept or God is an object. God is intelligence, love, whatever, or God is that guy with a magic wand in his hand. Okay, so if it's a thing, it's a man, it's a wizard, fine. Point to him, draw him, make a picture of him, a statue, whatever he is. Show us what God is. If you think God is a concept, just an abstract concept, and that's what you pray to. You pray to intelligence, you pray to love, spirit, whatever it is. Fine. We need to know which one God is. So tell us what ether is. Is ether an object? Is it a concept? If it's an object, we want to see something in front of us with a background. We want to see some shape. If it's a concept, define it. That's how simple it is. Okay? Shape, point to, concept, define. Black and white. That's all it is. Okay, so ether is either equal to space or it ain't. It can't be both. So you can't say, you can't use it in both ways. You can't say ether is space and also is within space. No, if space is a container of ether, ether is something separate from space. And if you say that space is ether and there is no difference, well, then you have to tell us that as well. It's got to be one or the other. It can't be both. And that's not very clear to all etherists. Okay, you have these different sects. Okay, is it finite or infinite? I mean, if the ether is equal to space, is that finite or infinite? And if it's infinite, it's not an object. It's not a thing. You can't use it as a thing. You can't say, I'm going to vibrate the ether, because you haven't defined it as a thing. So it had better be finite. But if it's finite, then you got to tell me what's on the outside of it. See how simple it is? Very simple, straightforward. Okay. And does it move? If it moves, it's a thing. Okay. But you can't say a little bit of it moves. You can't say the ether is all this background that covers the entire universe, but I'm going to shake a little bit of it and I call that the shaking of the ether. If you're going to shake the ether, you got to move the whole thing. And good luck with that one.
You're moving the whole thing, like if it were like this, like if we're a single thing, you're moving it like that. You're going to shake the entire universe. That's a big wave. But if you're going to move a little piece of it, a little region of ether, don't call it the ether. Now you're talking about something else. Now you're talking about the ether made of segments, of particles, of parts. That's not the ether. The ether is the big shebang, the whole shebang. Okay. Okay, and again, if it moves with respect to what? So these are the action items that people who propose the ether have to come through with. They have to answer these questions before they can give their presentation. We don't care about their theory at all, really. We want you to identify the ether. Spend 2 years on your ether because we still don't know what it is. People say it's a fluid. That doesn't explain anything. By saying it's a fluid, it's like saying water is a fluid. Yeah, and what is water? What's a fluid? Yeah, I mean, point to it. Okay, if it's a fluid, then it's got to have shape. Okay, and if it has shape, I need to know what's on the outside of it. So don't tell me it's just a fluid. It's a moving fluid, a vibrating fluid, or whatever. Okay, so here's the first individual. He says, the ether, same thing as plasma. Okay, so ether is that plasma, that I guess all those little bees that you see there. Okay, that's the plasma. What is plasma? Plasma is a dynamic concept. That's what plasma is. Okay, and why? Because what plasma is ionization of every atom or most of the atoms in that pile of sand that you see there. So plasma is something that is always in motion because it's ionized, and ionization is a process, not a thing. There is no such standalone thing called ionization. Ionization is a process where an atom loses or gains an electron. And that process requires at least 2 frames of the movie. You cannot synthesize it in 1 frame. Therefore, if plasma is ionization, plasma is also a moving thing. It requires 2 frames of the universal movie. Okay? But he says is inside space. So he's saying if it's inside space, he's saying space is some kind of container. Now we need to know what's outside of space. Okay? We know what's inside, it's plasma, what's outside of space. But then he says space is nothing. So if space is something, now he says space is nothing. Space is a container, it's something, but now he says space is nothing. So he's got a contradiction. Why? Because he never defined the word something or nothing. He never defined these 2 words. So he has no idea what something is, what nothing is, and he just uses these words thinking you know what he's talking about, what's going through his tiny brain. Is there part of the universe which is empty? Yeah, between your ears, that's what's empty, okay? He says empty. Empty is what space is. Space is nothing. And he says, is there a part of the universe that is empty? Yeah, let me illustrate what he's missing, why there is part of the universe which is empty, completely empty. Here it is, okay? Matter is the stuff you see. The black stuff is not matter. The black stuff is emptiness. There is nothing there because that is the definition of nothing, which is that which has no shape. Otherwise, you would not be able to see the atoms and the ropes that interconnect the atoms. Okay? They wouldn't have shape. You would have a single block of matter instead of matter being seen in pieces like that if space did not exist, if this nothingness did not serve as a backdrop. That's the issue. Okay, so yeah, there is something called nothing, and that's what you call emptiness, and that's that black stuff there, because you have to define what the word something and nothing is. The stuff you see moving there, that's called something, and that has shape, and all of that has shape. The little balls, which are the atoms, and the atoms that interconnect them. And the black stuff is the nothing, that which doesn't have shape and serves as a backdrop to that which has shape. And nothing is what chisels something, so to speak. Okay, we got that? Okay, so the fellow says, ether is not nothing, it is something. Okay, thank God for that, right? Okay, ether is a soup inside the nothing. Yeah, again, you can't be inside the nothing because nothing is a concept. You can't be inside a concept. Okay? Plasma ether is more concentrated the further you get away from a magnetic field because the magnetic field repels it. So here we have a field, which is a concept that repels the plasma, which is another concept. We have concepts repelling concepts. We have love repelling intelligence. That's what we have here. And nobody's been to the moon. Oh, Jesus. Because, why? The area around the Earth's magnetosphere is full of plasma. Okay, so I guess we can't go through plasma? Is that what it is? I mean, who knows what's going through this poor guy's little brain? But what are these people doing in science? They don't even have the ability to stay within science. They don't have the foundations. They have to take kindergarten 101 before they can come into science. Okay. Okay, here's another fellow. He says, ether can be treated like a continuum. Oh, okay. Because it is made of an infinite amount of objects. Okay, well, that's not what a continuum is. A continuum is something made of a single piece. It's the opposite. See, this was Aristotle's notion of continuum, something made of many parts, because that's the mathematical notion of continuum. In physics, it's the opposite. Continuum means it's made out of a single piece and not made of parts. Pile of sand is not a continuum, even though every grain is touching each other grain, assuming that were the case, or water's touching, every molecule is touching every other molecule. That's not a continuum. That's called discrete or segmented, made of parts. Continuum made of a single piece, okay? He says, most ether theorists have defined ether as being made of many, possibly infinite amount of particles. Okay, no, you can't have infinite amount of particles because infinite is an irrational term. Infinite means you're still counting, okay? If there's infinite number of whatever, okay? So we don't introduce the word infinite into science, or much less into physics. Think the ether is continuous. Well, if it's continuous, it's made out of a single piece. Then it would be continuous. Otherwise, the ether is made of parts, and it's not continuous. It's segmented, made of parts, made of points, whatever you want to call them. Continuums aren't actual objects. Yeah, it could be if it's made out of a single piece. Yeah, could be. But rather mathematical representations of a group of objects' behavior in a single object. Okay, so you're talking about behavior, not talking about structure. A continuum is not an actual fluid because fluids are made from more than one thing. So the guy went completely around in circles and we don't know what he said. That's essentially it. Okay, here we have another fellow. He says, what? He says, the fish analogy, which I used the other day, and there you see it on the right, is completely wrong. Wrong way to represent any version of ether. Yikes! A light wave should not be thought of as a separate object like a fish. Yeesh! So you can see these guys are so ignorant, so arrogant. They know everything. Okay? Mechanical wave in a medium is merely a behavior of that medium. Okay, so he's saying we have an ocean and it behaves somehow. Okay, a wave travels. Wave travels? How can a wave travel when a wave is a concept? You can say the flag traveled, not that the waving of the flag traveled. Okay, so that's when they say, oh, you're doing semantics, Bill. See, you're using word wizardry. No, I'm just repeating what he said. He's saying a wave travels. No such physical object called a wave. That's where the problem is. He's introducing words of ordinary speech or of mathematical physics into science. He can't do that. Okay, there is no physical object called wave. You can't use the word wave in science. But he says a wave travels, he's treating it like an object, through a medium. Through a medium is not an object. Okay, it's a behavior. Correct. A wave is a behavior. It's a verb. That's why we don't treat it as an object, and we can't say that a wave travels. Okay, it says a wave isn't some separate thing inside a medium. Okay, then what is it? It's the medium doing things. So wave is a verb. Okay, it's what the medium does. So you need to identify the medium, and either you identify the medium, the entire ether, for example, the entire ocean, and say that's the ether, the whole ocean, or you identify a portion of it, which is what you're going to be vibrating with, what you're going to be waving. And in that case, you can't say the ocean is waving. You can say the water in some location, some region of the ocean is waving, but you can't say the ocean is waving because that's not what you're talking about. Okay? Looking out onto an ocean with waves coming into the shore, there's nothing there but water behaving. Yeah, water behaves, correct? Now we've got the right word, water, okay? You can say water, you can say molecules, you can say atoms, but you cannot say the ocean is behaving, okay? The wave are traveling. Do they exist without the water? Right, you got that part right. So let's go slowly with this all. Let's see if he understands what he said. Okay, here we have it. Here's the ocean. Okay, let's go slowly. Let me remove this one here. Here's the ocean. Okay, single block of water, okay, or matter, whatever you want to call it. Let's assume it's static. We're just looking at a single frame of the ocean, cross section of time. Okay, we're looking at just one ocean. That's all we have there. Okay, one picture, snapshot of the ocean. Okay, now let's go in there and wave something. Okay, here's one wave inside the ocean. That's just one wave. Okay, is the ocean waving? No. Water is waving somewhere in the ocean. So we should not talk about the ocean at all. We cannot talk about the ether, which is what the ocean represents. The word ocean here is the word ether. Okay, and they're saying something is vibrating within the ether, the water. We want to know what the water of the ether is. That's the question. Okay, I hope we got the question right at least. Okay, so we had the ocean. Okay, and that's the ether. Okay, now we're going to vibrate a little region of the ocean, which he called what? Water. Okay, so what do we call a region of the ether? That's the million-dollar question. Because here you have many waves. Let's see if we can put this up here. That's many waves. That's the ocean with many waves, each one with a little region. Okay, but this is the issue. The issue is here we have a single region of the ocean. He called it water. He says you can't have wave without the water. Correct. We don't care about the word ocean. We don't care about the ether. Now we're talking about the piece, the segment, the region of that ether which is moving. In the case of the ocean, he calls it water. We need to know what water is in case of the ether. That's the million-dollar question. Okay, so if you have many waves like you just saw, this is what you have. There you have the ether. You have all these regions of the ocean, and they're vibrating. And when they say, look, it's the ether is vibrating. Well, no, the ether is not vibrating. What's vibrating there is every region of the ether is vibrating. You see the water molecules, so to speak, of the ether, which are vibrating. We need to know what the water is that you call, the composite of which we call ether. Okay? And so here, if you look at one of those regions, you expand it, this is what you would find. Okay, they say, well, the vibration of the ether. No, that's the vibration of the water within the ether. And again, you have to tell me what the white dots are. You can't call that ether because you're talking about a region of the ether. And for that, you need to define. That's what you need to do. You need to tell us what the physical object is. And until you can identify the water of the ocean, the water of the ether, right? You can't even start your presentation. Okay, another fella, he suggests an experiment. Okay, this is what they did. There is an easy way to solve this. Okay, good. Go to space with a clear air-proof, waterproof ball. Okay, open it in outer space and close it back to have the ball filled with ether. Okay, bring the ball under water and open it. If a bubble forms, then space is a medium, ether. If you see fume waves, then space is a gas. If nothing happens when the ball fills with water, then space is a vacuum. Okay, so this is what people have going through their brains. They have all these things that they think they can prove through an experiment, what the space is out there, which they call the ether, which they say is within the space, and that space is a container, and they don't know what's outside of this container, giving it form. They talk about infinite particles. They say the space is infinite, the ether is infinite. Then they say, we're going to vibrate the ether, and they're not vibrating the ether, they're vibrating the water within the ocean. So they have all these contradictions. They never resolve these. They never, and this is a question of rationality. You have to resolve these issues before you can give your presentation, before you can talk about the ether or anything else. But they don't do that. They just go directly in there. And if you question these things, you're doing semantics, Bill. You're doing philosophy, ontology, whatever it's called these days. Okay, here's another fellow. Okay, let's get him up here. He says, light doesn't require a medium. He's saying, we don't need this ether thingy. I guess he says they proved the non-existence of the ether, okay, of this medium. There is no medium out there, okay, and so here you have light, and we talk about the motion of light. In fact, he says light is moving the fastest in a vacuum. Light slows down in a medium. Okay, that's what light does through the water, through the ether. Fine. But he doesn't tell me what light itself is, but he says it doesn't require a medium. So he's talking about light moving, and how can light move if light is not a thing? If it's not mediated by something, okay? If light has no medium, what is it that is moving? Nothing? Is it a concept that's moving? So this is the issue. You have to define the word motion, and that's why this guy is not even in kindergarten physics. He doesn't understand what motion is. You need two locations at least of a medium to talk about motion. That's the definition of the word motion. Once you have that definition, you cannot say light does not require a medium, because then what is it that is moving? What is it that occupies two locations? What occupies two frames of the universal movie if there's nothing there? Okay, if it's a concept or who knows what he's got in his mind. And then yes, you see there the little c is equal to frequency times wavelength. That's the equation of a rope. Okay, that's what the mediator is. That's what's moving. That's what's vibrating, in this case, torquing. Okay, and all we have is a difference between segments of the rope. For a given length of rope, you have more links, and the links are shorter. And if you unwind the rope, well, then you have fewer links, and the links are longer. And that's what that equation represents. C equals frequency times wavelength is number. C is equal to number of links, and wavelength is the link length. That is the equation of a rope. Only a rope can simulate that equation. Okay, so that's where we're at. And here you have a definition of what an object is and what motion is. Okay, an object is that which has shape. You need to have shape. And so to say that light has no medium or is not mediated by anything is irrational, because you're going to talk about motion. And so the question is, what is it that moved? Motion, two locations of an object. And there you have a film of the movement of something and a film of the movement of nothing, which is what this fellow proposes. Okay? So again, I don't know what these people really have in the back of their minds when they talk about light moving. How can light move if it's not a thing? You need to have a thing to conceptualize motion. And here you have, let me make this bigger. Give me a second here. Here you have why the rope is a good model for light. Because light has that equation. The velocity of light is 300,000 kilometers per second. Okay, it's a constant, and it's a constant between any two atoms. It doesn't matter what object it belongs to, and it doesn't matter what light goes through. Between any two atoms in the universe, at least in the known universe, right? Light has the same speed, the same torque, because all you're doing is changing frequency in exchange for wavelength. If frequency, meaning more links, are there, then the links are shorter, and vice versa. If the links are longer, you have fewer links. And what you have here is, you can see white light coming in there, and again, this is just a picture of what happens through a prism. When light goes through the prism, you can see that between atoms, the links are of different wavelengths. There are different number of links. And what comes out is all these colors. And what are colors? Well, they're different link lengths and different what we call frequencies, meaning number of links. Okay, so for a given rope, length, right? You can torque it more and torque it less, and you're going to get different colors, meaning different frequencies. And this is easily shown. With a rope model, it's perfect. There you have few links. I don't know how many are there. What is it, 2 or 3, right? Now we're going to torque it some more. It's always the same piece of length. That's all the rope I've got, okay? I'm not introducing more rope in here, okay? Now you have more links, and each link is smaller or shorter, okay? And now we untorque it. Now the links become longer, and there are fewer links. And what we have, this is the equation of a rope, C equals frequency times wavelength. It's always the same amount of rope. Okay, so for this given length of rope, you can simulate why light always is a constant between any two atoms. All you did was change the number of links. That's it. Okay, that's the theory. Now, some people say, well, if you torque it more, the rope kind of shrinks, right, and becomes shorter overall, right? The rope is a little longer if you have, the links like this, right? The longer links. Then if you torque it, it tends to pull all the links closer together also. And yeah, the answer is very simple. Remember how the atom is constructed. It's constructed by these same threads. So the atom slides through these threads, and the threads are being fed into the rope. So the slack is taken up from the atom, which is taken up from another rope, which is taken up from another atom, which is taken up from another rope. When you pull on a rope, in a sense, you're pulling on the entire universe. That's what you're doing. The atoms are sliding along the ropes, okay? And because the ropes construct the atoms. So there's no mystery. The rope can become a little longer, a little shorter when it torques more and torques less, because it's borrowing slack from atoms, which are buying it from another rope, which are buying it from another atom, and so on down the line. Okay, here we have another fellow, and he says, all of those have motion because they are all made out of moving molecules. So I showed the other day how solid, liquid, and gas is something you point to. There you have a liquid. We took a snapshot of it. Does that have shape? And the answer is yes. Gas, you take a snapshot of gas, whatever gas, if you could see it, and it has shape. And same with a solid. And this fellow is trying to say that plasma and fire also have shape when you take a snapshot of it, and that nevertheless, fire and plasma have stuff that's moving in there. They're dynamic entities, you could say. But for that matter, so is gas, liquid, and solid, because they are made of atoms which have electrons, and the electrons are also moving within those atoms. That's his argument. Okay, he says all molecular objects are processes by the same standard. Liquid and gas embody motion too, fluid motion. Well, again, one of the problems with these people, they've never taken high school physics or kindergarten physics. That's why I look at it. Okay, so let's educate this fellow. Let's go slowly because they have problems understanding all this stuff. Okay, here you're going to teach the Klingon your language. You point to a tree. Are you thinking about the atoms that comprise the tree and whether the atoms and the electrons within the atoms are moving when you look at the word tree? No, you point and you say tree. Tree is that thing there. You can take a snapshot of it. You can make a picture of it. You can bring a mock-up of it. You can bring the actual tree. You're not thinking of the atoms that comprise the tree and whether they're moving or not, or whether there's a wind that moves the tree. The word tree represents a static concept. Okay, it is a static concept. The word tree, right? Tree, you point to and you say tree. It's an object, and you're not thinking of what it's made out of and whether it's moving. Okay, the word tree does not embody motion. We got that? I know it's kindergarten stuff for us advanced people, but for some of these people, it's a big jump in their intelligence, in their understanding. Okay, here, now you're going to teach them the word table. Okay? You're going to teach them the word table. What is a table? Well, a table is what I pointed to. It's that thing over there. I point and say table. That's the way you do it. And are you thinking about what the table is made out of? whether those atoms are moving, the electrons are moving within atoms. No, you're not thinking about any of that. The word table does not embody motion. The word wall, the word rock, none of these embodies motion in the word rock, in the word table, in the word chair, wall, etc., ground. Those are static concepts. The words are static concepts. They don't embody any motion. There is no motion involved in there, no action. Let's go now to another. We're going to teach the Klingon another word now here, okay? Let's find out. This is the word, went all the other to the other side. Give me a second here. Let me get it back. You're going to teach them the word ion. Can you put the word ion in a single frame of the movie, of the universal movie? And the answer is no. You point and you say, well, that's a ball with a plus sign out over it. What does it stand for? Well, I mean, there's two objects there. There's a plus sign and a ball. And you have to explain to him that, well, something's happening. Okay, what is it that's happening? Well, in order to explain happening, behavior, action, you need two frames of the film. You need motion. Okay, and that's what you got to show. You got to say, look, what happened is the atom lost a marble, lost an electron, lost a ball. So, but for that, lost, got rid of, is a verb, is an action. There's something going on. You need two frames of the film, of the universal film. You got to show first one frame where the ball is there and the other one where the ball is no longer there. That's an ion. An ion means something happened to the atom. Ion is not a standalone object. Ion is something happened to this atom. That's what the word ion means. And that's what the word plasma means. You can't point to plasma because plasma is ionization. Ionization, you need two frames of the film because you got to explain to the Klingon in this case that the atom lost an electron. For that, you need two frames of the film. That's what plasma requires. That's what plasma is. You can't point to plasma because plasma is a verb. It's an action. It's a process just like fire. The word plasma embodies motion. The word stone, the word table, the word ceiling, wall, rock, tree, none of those embody motion in the word itself. The word plasma does. The word fire does. The word wind does. All these words embody motion. You cannot have wind in one frame of the movie. If you have wind in one frame of the movie, you have air. So far you have air. So far you don't have wind or hurricane or tornado or vortex. Okay, we got that? This is kindergarten stuff. Okay, so if you don't understand that, you flunk kindergarten. Okay, kindergarten physics. Okay, Winfeld suggests that you can pull with a corkscrew mechanism. He says, what can you throw at something that will attract it? Notice that he says throw. Okay? He says, what can you throw at something that will attract it? He says a corkscrew, cyclone. Okay, because he's saying that action at a distance, you can throw like a stone at something and attract it. Okay, that was the issue. He's trying to explain gravity by throwing something one way. And he's going to say you can do it with something like a corkscrew, which is more or less like water running down a drain. He says radiation moves in outward spirals. Radiation moves. Radiation is a concept. There's no physical object called radiation. But he doesn't understand that because he hasn't gone through kindergarten physics. Gravity is a reciprocal force, just like water spiraling down a drain while air is simultaneously pulled upward out of the drain. All motion is two-way. Okay, so the issue here is that water rushing down a drain, water is made out of molecules, they're going one way, okay, and it's you would have to have infinite water for that to happen, okay, for it to go always forever in one way, okay. But that's not the same thing as the corkscrew that you see on the left. The one on the bottom left, you can say that that's already connecting two ends, source and target, okay. That's different than something being thrown at something else. So when he says when you throw something, he's talking about the water going through the drain. He's not referring to the corkscrew. But for him, he sees nothing different between the corkscrew and water rushing down the drain. These are not the same scenarios. Because if you're going to use the corkscrew, then you're talking about something like the rope, where something is already connecting physically one object to the other. Okay, that's different, and you can't use words such as radiation or spiral or vortex or anything like that, because those are not physical objects. You got to tell me what physical object is torquing. In this case, I'm showing a corkscrew, the mechanism there. It's a mediator, no problem. But then you have to show that and say, what is that thing that you're pointing to there? You cannot talk about water rushing down a drain and say that's the same thing as a corkscrew. But this fellow doesn't understand these basic things. They're so smart, they're so arrogant, they know everything. So they don't even understand these basic things. Okay, one fellow says, why can't I use black magic as my mechanism? Okay, why can't he? Can't we? Explain with black magic. Isn't that a mechanism? The answer is no. Black magic, no mechanism at all. Because black magic, you cannot see the mechanism. You're just showing what I show there, a spoon over here and it falling to the floor. And you cannot tell me what caused that spoon to fall to the floor. You see the spoon, see if I can do this, okay? You let go of it and it falls to the floor. So it falls and you can't see the mechanism. And so black magic is no mechanism at all. Make a movie of your mechanism and then we'll know whether black magic can pass the test. Okay, and finally we have a fellow who, also a flat earther, who brings it into the topic of extinction, which we're very close to. Here we have the war in Ukraine and all this stuff, right? Inflation, there's going to be more unemployment, the interest rates are going to rise, I guess. Who knows? We're going to have a great couple of next years, okay? But here this fellow says the following. He says, you guaranteed a bold prediction that we are the last generation of humans. No, I made no prediction, okay? And again, this fellow was educated by the establishment. He talks about prediction. He uses these words such as prediction. And so he doesn't understand the difference between a prediction and an explanation. That's where the problem starts. Despite the best mathematical concepts, not even economists can make reliable predictions in either the short or long term. Yeah, we're not talking about predictions at all, and he doesn't understand that. A mass extinction event involving a collapse of the food chain triggered by the value of money going to zero. Yeah, ergo, no farming because no money, global starvation inevitable. You do know money is no object. Yeah, no kidding. Money is a mathematical concept. Hey, he's a smart fellow, okay? Economics doesn't deal in explanations. Economics is not science. Poor fellow. Again, it's because he doesn't define his terms, so he thinks all of this is a prediction. And all I can recommend to anyone who uses the word prediction, here it is, synthesis. You have to do extinction 101 before you do extinction 102. First, you got to tell me past extinctions. Explain past extinctions. Give me the mechanism of how species in the past, which are already in the ground, their bones are in the ground, their fossils are there. You got to tell me how those became extinct first. Okay, once you have a mechanism, a physical mechanism, once you can explain how those animals, plants and animals, etc., in the air, on land and sea disappeared, okay, once you have that, that's extinction 101. Now you can tell me, now you're an expert to tell me something about human extinction. And no, it's not a prediction. It's called an explanation. We're explaining the mechanism of how humans are going to disappear. We're not making a prediction. A prediction is on the 1st of May of the year 2030, the last human is going to die. That's a prediction. We don't do that here. We can't tell you when the last human's going to die. All we can tell you, which is extinction of the human race, right? No, we can tell you the mechanism, what is going to cause the extinction of man, because Mother Nature uses the same cookie cutter on all species. And she used this mechanism on all species in the past. Once you get the cookie cutter, once you know the mechanism, you apply it to man and see if man can avoid that same mechanism. And it turns out it's economics, science. Yes. And so there, first you got to take extinction 101 before 102. It's not a prediction, it's an explanation, okay? And mechanism of mass extinction is economics. That's why economics is an explanation. All animals have economics. Economics is the management of resources. All animals manage resources. They manage one resource specifically. It's called food. All animals manage food, and that's known as economics. And when food runs out, the animals run out. That's more or less, in a nutshell, a mass extinction. And the same thing will happen to man. Man will disappear in a mass extinction, not in a background extinction. We're the last of a dynasty of hominids, monkeys, whatever you want to call us. Mass extinction, disappearance of an entire food chain. That's what a mass extinction is. And we're due for extinction very soon. Okay? You got to explain the extinction of the animals in the past. Then you can talk about the extinction of man. But these people skip that step because they know nothing, absolutely nothing about paleontology. They know nothing about how animals disappear. They don't even have an idea. They just borrow from the establishment and they say, oh, I think the dinosaurs died when a comet hit the earth. And that's all they know. They don't even know who the animals of the Permian are, or the Triassic or whatever. They have no idea whatsoever. And they say, oh, but I'm an expert in human extinction. I know humans will never die, or if they die, they'll die because of what? Climate change, disease, what is it? What other ones are there? Peak oil. You know, they have all these. Maybe a comet will hit the earth. Okay, so they know nothing about extinction, but they're experts. Okay, we had our science critic. Let's get to him. Our science critic. And what did he say? Well, he had something to say about the scientific method. And he says that something in the scientific method, the important part of the scientific method is what they call falsification, which came from Mr. Karl Popper, a supposedly philosopher of physics, whatever that is, philosopher of science. Okay, let's listen to him. This is what he's got to say about science and whether falsification plays any role whatsoever in it. Here he goes. Give me a second. Okay. Here he goes. Listen carefully.
The questions and issues to be addressed in this rebuttal include: can an equation explain what caused a phenomenon? And does Popper falsification have anything to do with science?
An equation can tell you why things happen. If you want to know why things break when they fall from a 10-story building, an equation can help you with that. And the thing is, equations allow for specificity. If you do not have any specificity, it makes it very difficult to test your ideas. So you pretty much need equations to be able to test ideas. And if you can't test ideas, then that makes that idea unfalsifiable. And as we've discussed, unfalsifiable ideas are irrational.
Of course, if he doesn't define what irrational means, if he just says anything that's unfalsifiable is irrational, you know, that's absolute nonsense, has no validity. He hasn't defined what irrationality is. But we're going to skip that for today. We're just going to get to the following. Here you have an equation. Force equals mass times acceleration. Okay, does that tell you why the box came up? In the case of the pulley, does it tell you how the window broke? If you just say force mass times acceleration, you know, someone gives you that equation and says force equals mass times acceleration. What have they explained with that equation? Okay, and there you have the spoon falling to the floor. You know, again, a force, a mysterious force. You still don't know the mechanism. So no, mathematics can only describe, and a description is not a mechanism. It doesn't give you any idea what caused something to happen. And as far as falsification, you know, I mean, we don't falsify anything in science, but here's Mr. Popper's synthesis. Okay, this is what Popper believed in. This is what he proposed for science. Okay, and Popper says he believed that scientific knowledge is provisional, that it's an ongoing process again. That's what people just memorize and just repeat. They say, oh, it's an ongoing process, the best we can do at the moment. And so they never answer the questions because they say, well, we still don't know, we're still investigating, and science is just a process of investigation. That's all it is. And all they do is just measure, get equations. They say they have ever more accurate equations, and they have no explanation, no rational explanations whatsoever. Okay? They always explain with the motion of concepts. That's why they're irrational. And it says Popper is known for his attempt to refute the classical positivist account of the scientific method by replacing induction with a falsification principle. Okay, what is the falsification principle? Well, it's proposed by Karl Popper, is a way of demarcating science from non-science. Okay, so the guy who doesn't do falsification is a non-scientist. Okay, it suggests that for a theory to be considered scientific, it must be able to be tested and conceivably proven false. Proven false to whom? To the Pope? I mean, these people are talking about belief. They're not talking about science. So Popper had no idea whatsoever. Okay, he thought that science had something to do with belief, with proving, with convincing people. And so he's saying it's got to be tested. Okay, tested for what? So that I can convince you that my theory is correct, meaning belief. Meaning I'm going to twist your arm. It's got nothing to do with science. It's got to do with belief, and belief is religion, not science. So what Karl Popper defined was the religion, not science. For example, the hypothesis that all swans are white can be falsified by observing a black swan. Okay? Yeah, it's a hypothesis because you're making an assumption, but these people are talking about theories and they call that a hypothesis. For Popper, science should attempt to disprove a theory rather than attempt to continually support theoretical hypotheses. Okay, and again, what Popper talked about is not science. He talked about religion. Religion is about belief, about proving, about testing. Testing for what? For verification. Verification for what? To convince. Convince for what? To prove, to persuade, to convince, convert, recruit. It has to do with belief. So what Popper defined has nothing to do at all with science. And yet descriptions are not science, explanations are science. It doesn't take any mental capacity, any mental effort, any energy, to describe something. So the pencil fell to the floor, great. And I do the experiment, I describe it, I can tell you how fast it went, what the acceleration is. I still don't know why. I have no cause, no mechanism. That's where you have to break your brain. That's where you have to try to visualize the invisible world of Mother Nature. With that, I'll see you next week, next Sunday. We'll see you then.